Let us now study about the properties of magnet. Number 1. Magnets can attract only some metals. Students, magnets cannot attract all objects. Magnets attract only some metals like iron, nickel, and cobalt. Magnets do not attract other metals. Magnets also do not attract other materials like wood, books, copper, brass, plastics, rubber, and so on. Substances which are attracted by magnets are called magnetic substances. The examples of magnetic substances are iron, steel, cobalt, nickel, and so on. On the other hand, substances which are not attracted by magnets are called non-magnetic substances. The examples of non-magnetic substances are wood, plastic, paper, glass, copper, brass, rubber, and so on. Now, let us learn about the other property. Students, poles of a magnet are located near the ends. The attracting power of a magnet is maximum at the two ends and minimum at the middle. Students, these two ends of a magnet are called the poles of the magnet. Students, now let us perform some activities. Here is the first activity of this lesson. To perform this activity, spread out some iron fillings. Or if you don't have any, you can spread some common pins on a piece of paper. Now roll a bar magnet on the pins. What do you observe? You will find that most of the iron fillings cling near the ends of the magnet, isn't it? While there are very few iron fillings, or if you're using the pins, there are very few pins at the middle. Students, why are more iron fillings or pins attached at the ends? It's because the two ends of the magnet have the greatest attracting power. So, they attract more iron fillings or pins. Now, let us move on to the third property of a magnet. Students, freely suspended magnet always points in north-south direction. When a bar magnet is suspended freely and horizontally from a thin thread, the magnet will come to rest, pointing to the Earth's north and south directions. Students, the end of magnet which points towards the north is called the North Pole, and the other end which points south is called the South Pole. These north and south poles are marked by the letters N and S respectively. Let us perform an activity. Students, take a bar magnet and suspend it freely, as shown here in the figure. You will see that the magnet comes to rest after some time. Now observe the direction pointed by the two ends of the magnet. Again, disturb the magnet a little from its position of rest and allow it to come to rest. What do you observe again? You will find that the magnet always points to the same, that is, north-south direction. Here is the fourth property. The like poles repel and unlike poles attract. Students, when the north pole of a magnet is brought close to the north pole of another suspended magnet, the two magnets repel each other. But when the south pole of a magnet is brought close to the north pole of another suspended magnet, they attract each other. Let us perform an activity. Take two bar magnets. Suspend one magnet freely by a piece of thread as in the previous activity. After a while, the magnet will come to rest in the north-south direction. Now bring the north pole of the other bar magnet near the south pole of the suspended magnet. Do you observe the attraction between the two poles? Now, bring the south pole of the other magnet near the south pole of the suspended magnet. Do you observe the repulsion between the poles? Obviously you do. Now let us move on to the fifth property. It says, each magnet has its own magnetic field. Students, the effect of a magnet is felt in a certain region around a magnet. If you place a compass needle near a bar magnet, the compass needle swings and then rests in a definite direction. When the compass needle is taken away from the magnet, the influence on the needle slowly decreases. The effect on the needle completely disappears after a certain distance away from the magnet. This clearly shows that the effect of a magnet can be felt in a certain region around a magnet. Students, the region around a magnet in which its influence can be felt is called magnetic field. The magnetic field is stronger near the magnet and decreases with the increase in distance from the magnet. Here is an activity. Place a sheet of white paper over a magnet and sprinkle some iron fillings on the sheet. Tap the surface of the sheet gently. What do you see? You see that the iron fillings arrange themselves with a definite pattern, isn't it? Why do you think this happens? Can you explain? Let us look at the other property of a magnet. Students, magnetic poles always exist in pairs. In a magnet, north and south poles exist in pairs. They cannot be isolated. If a magnet is broken into two pieces at the middle, each piece will become a complete magnet containing a north and a south pole. Students, if the two pieces are further broken, each smaller piece still acts as a full magnet containing both the poles. On breaking the pieces of magnet further, produces a large number of magnets with both the poles at the ends. This clearly shows that the poles of a magnet cannot be separated and always exist in pairs.